Alright, hi everyone. So today will be the lesson 5. Okay, so lesson 5 for our chapter Discrete Random Variable. So we'll be having like 2 more lessons, so meaning today's lesson and Monday's lesson that we are going to finish this chapter. Okay, so for today, like we try to recall the lesson. So the first and second lesson, you learn what is a discrete random variable. You learn how to find the probability distribution, and you learn how to find the mean and the variance. Then after that, for the third and the fourth, we learn about binomial distribution. How do you how do you apply the formula, and then how do you find the mean and the variance also. So for today's lesson and Monday's lesson is going to be a new distribution, which is called as geometric distribution. Okay, so you see for the learning outcome, it consisted of 2 parts also, which is the first one, how to use the formula for the probabilities for geometric distribution, and same thing, how do you recognize the situation where you need to use geometric distribution. And after that, the second part, you have how to use the formula to find the expectation. So for the geometric distribution, you do not have variance here, it's only mean, which is expectation. Okay, which this part we will be covering up on Monday. Alright, because I want to try to make like the lessons like not so intense, so we can go like a little bit slow pace, so you'll be able to catch up faster. Okay, so for introduction today, alright, so when you look at the picture, right, sorry, I'm having a little bit flu, so I hope that my sound doesn't sound like very awkward here. Okay, so for this question, then you have like for example, like when you were young, I guess like as Malaysian, you should be able to play this board game before. Okay, so when you play this game, right, what happened is every time when we start the game, what happened here is every player, they must get a 6. Like when you throw the dice, you must get a 6, then only you can able to like go out from your house of your chest. Then after that, you only can go out and move on the board. Okay, so this is what happens. So you see, like every time, right, when you play it, you know that the chances or the probability for you to get a 6 on the dice is basically 1/6. But what is the probability after that? So meaning after each round, right, we know that as we try on, then like the probability for us to get 1/6 maybe is like, because of we did a lot of trial, so that's why the chances for you to get like 6 will be higher. But then meaning, what is the probability when we try to combine them and look at it in a bigger picture? Okay, so now you see, let's try to explore this with what we have learned before in binomial distribution. So if you still remember, in binomial distribution, we talk about like we have finite number, a fixed number for your trial. Then after that, you have 2 outcomes, which is the success and the failure, and the probability of success and failure is the same when you carry out every trial. Okay, so let's say now for us to play on this chess, right, what happened is I need a 6 so that I can go out from my house and then I start moving on the board. So let x be the number of trials needed to get a 6. So meaning the success for us is basically to get a 6. The failure for us is basically not getting a 6. Okay, so now we do not want to like explore the real probability first. So let's try to do this like in the same thing that we learn binomial distribution, which we say the success is P, then the probability of failure is Q. Okay, what is the probability for me to get a first 6? For me to get a 6 when I roll the dice for the first time. Okay, I think this is very obvious, which is 1/6. Which I'll write P here. Okay, you get it right? So meaning that the probability for me to get 6 on my first row is basically equals to P lah, meaning the success. Okay, so what is the probability for me to get first 6 on my second row? So you see, meaning that first time you didn't able to get 6, you're able to get your first 6 on the second row. So meaning that the first time is basically a failure, correct? Which is, we talk about real probability, then it will be 5/6, meaning the first time you fail to get a 6. Then after that, your second time you success, correct? So that's it. That is what it means by first 6 on the second row. So you will use the first one is like a failure, then after that the second one is a success. So this is how you get QP. So we try to arrange it like P in the front, then PQ. Alright, okay, so what is the probability for you to get a first 6 on the third row? So what does that mean? So meaning that your first trial and your second trial, you didn't able to get a 6, meaning that 2 times failure. So that's why you have Q. First time fail, second time also fail, and the third time I get a success. Okay, so QQP. So when I arrange, then I get PQ square. So meaning my third row I have a success, then after that previously I have 2 failure. Okay, so what is the probability for me to get a first 6 on the fourth row? So meaning that the first one I get a failure, second one I get a failure, the third one I get a failure, and the last one I get a success. Okay, so when I try to rearrange it, then I'll become 1 success and basically 3 failure before that. Okay, so when we look at this, right, now we want to put it into a table. Okay, so the first one is basically P, then you have PQ, so you have PQ square, and you have PQ power 3. So imagine if I go to 5, so meaning I want to get a first row on my first 6 on my 5th row, then what is that? So it's basically PQ power 4. For you to get a first 6 on your 5th row is basically you need to have 4 failure before your success, which is at the 5th time. Alright, okay, then when you continue, when we talk about n, so I'm not sure like whether you realize the pattern or not. So what is for n? So if you have n number, then basically you see everything you will have 1p, because your last time, meaning what is your r? Your r meaning is the time that you get the first success that you want. So meaning you will get the first success and n, and then after that, before that, you need to have how many times of failure. So you see, if your first success is at 4, then you get 3 times failure. If your first success is at the 5th time, then you get 4 failure. So if your time of success is the n time, meaning that how many failure do you have beforehand? It's like Q minus 1. Okay, so just like that, then this will be our formula for geometric distribution later. Okay, so now the probability of x, the number of trials needed to get the first success in a series of repeated independent trial, is a discrete random variable, and it forms geometric distribution. So this is basically the geometric distribution. Okay, so now let's look at the formula. Okay, so for geometric distribution n, the probability for the first success occurs on r trial, px equals to r is basically pqr minus 1. So what is your r? R telling you that what is the number of trials that your first success occurs. So meaning like you see just now, first 6 on the 4th row, so we have our r as 4. Okay, 4. Then after that, this is the the first 6 on the 5th row, so that's why your r is 5, and so on. Okay, so when you look about this distribution, right, so I hope that you can realize that you will find something like very similar for geometry, for the binomial distribution that we have learned previously. Okay, so now let's see what is the constraint for a geometric distribution. So the constraint for the geometric distribution will be there must be an infinite number of independent trial. Okay, let's go from this way. So your recap. Okay, for your binomial distribution, right, what are the 3 constraints? So if you still remember, the first one is like you must have a fixed number of independent trial. So this number, if we try to put in your formula, right, then what is that? Is your n. Okay? Yeah. So for every time when you carry out the experiment, you must have a fixed number n. So meaning how many times I tried, then out of how many times I got how many success, right? Okay. Then after that, what's your second one? So your second one is the same thing. You must have two possible outcome only, which is the success and the failure lah. And then your third one is about this possible outcome. The probability for the outcome must be a constant. So this is for binomial distribution. Okay. So now when we look at the geometric distribution, what do you realize? So you remember just now we talked about the game for the chess, right? So we also put it in a situation that you get a 6 and you're not getting a 6. So it's the same thing for geometric distribution. You have only two possible outcome also. Okay, so you can see, look at this, you have two possible outcome also. And then you see every time for every trial, the possibility for me to get a 6 is 1/6. And for me to not get a 6 is 5/6. It's not going to change after trial and trial. So that's why the probability of the outcome is basically the same also. So what is the difference about this distribution is only this, the first one. So for binomial distribution, you have a fixed number of independent trial, but for geometric distribution, you do not have a fixed number. So it's like an infinite number. So what does that mean? So you see, the idea for geometric distribution is what is the probability for you to get the first success. So meaning that when I started to do my experiment, right, basically I do not know how many I need to do, because the distribution will stop after I get my first success. You get the idea, right? So meaning for binomial distribution, we can have like, sometimes you can have like out of the 15. Yeah, so for example, for the rolling dice example just now. So for binomial distribution, right, the thing that we want to find out will be like, maybe I roll it for 10 times. How many times I will get a success, which is a 6? That is the question that is the idea for binomial distribution. Okay, I repeat again. Binomial distribution help you to find how many number of success you get out of a fixed number of n. So meaning like I have maybe from what you have learned, so maybe like from 10 trial. So I want to find out what is the probability for me to get a success like, this for me to get success of 6 times. Yeah, this will be for binomial distribution. Okay, but for geometric distribution, right, we don't have that. We only say that maybe I want to keep on trying, then what is the probability for me to get the first success on the 6? So how many success you have? You only have one success, which is the 6th time. Okay, so I hope you can see the difference. So that's why for this one you have a fixed number. So if I want to check for 10 trial, then my n will be 10. But geometric distribution is like I can have all the different kind of n as long as I want to get the first success and at the term. Okay, so yeah, you can read through it yourself. Okay, then for a binomial distribution, if you remember for last time what we have learned, right, the dice that we have used. So you see for every probability here, you have a number of way of NCR. Okay, so meaning like for binomial distribution, your number of way will be equals to NCR, and then after that we use it to times all the probability together. But for geometric distribution, your number of way, how many number of way that you want? You actually have only one way. So what does that mean? So you see when we do the what is that called? When we do the chess game just now, okay, when you try to do all this, right, how many ways that you have? You actually only have one way. So if let's say my R is equals to 2, meaning that I will have one failure beforehand and I get the success after that. If my R is 3, then meaning I will have 2 failure beforehand and I get a success on the third time. So if I do R equals to 4, then I will have 3 failure beforehand, then I will have the success on the fourth time. So for geometric distribution, you only have one way to get the answer, which is like to get the first success on the R trial, and what happened is you will have a R minus 1 failure before your success. Okay, so I hope that you can understand the idea. I think it's much more easy than a binomial. So it's the same thing like a tree diagram. If I continue to draw it, but then we try to put it in a more proper way like that. Okay, so in your exam, the formula will be given like this. So it's the exactly same thing. So I write there PQR minus 1. So the same thing like binomial distribution lah, they didn't use Q, they used 1 minus P. So it's basically telling you the exactly same thing. And for geometric distribution, because we do not have a fixed number of trial, so that's why in your notation, instead of, so for binomial we write B and then NP, right? So for geometric, then we write, so please do not write G. So the standard notation is GEO. Sometimes when you look at binomial, sometimes they use BIN also, okay? But for geometric, so it's like GEO then P. Because you do not have a fixed number of n, so that's why your parameter you only have one, which is P, which is what is your probability of success. Okay, so remember this, that you can have your formula with you. Then after that, we are going to look at few example together. Okay, so now let's look at the example. Okay, now the first one. So this is about the chess game just now lah. Okay, I play a game in which I need to throw a 6 to start. What is the probability that I start on my fourth turn? Okay, so this is basically what is that called? Geometric distribution, which tell you that what is the probability for me to get a 6 on my fourth term. Okay, so you can write it down first. So this is basically a geometric distribution, which what is your P? The probability of success here is 1 over 6. Okay, so you have only one parameter. Okay, then after that, what is the probability for me to start on my fourth turn? So if I want to change this idea in another word, then it will be what is the probability that I get my first success on my fourth term. So meaning that it will be probability x equals to 4. Okay, so in geometric distribution, how do we interpret? Is basically I get my first success at the fourth time. So what is the probability for me to get my first success at the fourth trial? Okay, so after that you can use your formula. So for you to get your first success on the fourth trial, then it will be 3 times of failure beforehand, then 1 time of success. Okay, so 1 time of success and 3 times of failure before that. Okay, so just like that. Yeah, I hope that you find it like much more easier than the binomial distribution that you have learned previously. Okay, so after you use your calculator, then you should be able to get 125 over 1296, which will give you an answer 0.0965. Okay, so B, I have not started after 6th turn. So what does that mean? If I have not started after 6th turn, that basically meaning that for the 6th term, every time I get what? I get a failure. So the probability for me to not started after 6th turn, then it will be probability for me, my first success is more than 6. Correct? So that's what mean by I have not started after 6th term. So meaning that I might start at the 7th term, I might start at the 8, 9, 10 and so on. So you remember that is infinite number of your number of trial. So you are not able to find like 6, 7, 8, 9 and blah 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 because you do not know how many turn do you need to take. So what is the probability for I have not started after 6th turn? So when you try to figure it out in another way, if I have not started after 6th term, what does that mean? Meaning for the 6th term, every time I get a failure. So the probability for me to not started after 6th term is basically equals to I get all failure for 6 time. That's why I have not started. Okay, so that's why I get my answer 5 over 6 to the power of 6, which is 0.335. Okay. Alright, so for geometric distribution, right, you have one formula, but the other one you will realize when you answer question, right, you need a lot of like idea of thinking it in another way, which is you do not want to use like a lot of what is that called? A very long method to do this. Okay, let's say I actually want to find the probability for x greater to 6. Since I cannot find 6 to n, actually what I can do, I can start from first. So, okay, meaning that what I say here, right? Can I do this question like this? Probability for me to not get a 6 after my 6th turn. So meaning that my first success happened after 6th term. So meaning 7, 8, 9, 10. So in this case, then what I can do, I can basically do 1 minus probability x smaller and equals to 6. Then I use 1 minus probability for x equals to 1. So my first success at the first term. Then after that, my first success at the second term, at the third term, and the fourth term. Fourth, 5, 6. Can I do that? Yes, why not? You can do that. So it's the same thing like normally sometimes you will have a very like in binomial also or in discrete random variable also. So you have two ways to do that. Either you want to go for the long way or the short way. So like sometimes you want to do 1 over, like you use the what is that called, your failure in term instead of a success. So it's the same thing. So there's no right answer or wrong answer. If you use this, right, you totally get the same thing also. So later on question 2, I think I'm going to show that because this question is a bit long. Yeah, so you can try it out. But basically this question you can think it in a way that if what is the probability for me to not started after 6th term is basically equals to, for the 6th turn, for every turn actually I get a failure, so that's why I did not started. So you can straight away do failure power 6. But it's the same thing also if I want to use a complete probability, which is 1, then I minus out the probability for me to get first success on the first term, first success on the second term, third term, fourth term, fifth term, and the 6th term. Then I will get the probability for me to get x greater than 6. Okay? Alright, number 2. Repeated independent trials are carried out in which the probability of success in each trial is 0.66. Find the probability the first success occurs on the third trial. Okay, so in this question, is a geometric distribution also. So I hope that you can see the idea now. Is like the question will ask in a way like, what is the probability that your first success, normally they will use the word fourth, or like if not then number 1, then you need to try to identify yourself. The idea of the question is like, what is the probability for you to get the first success? Okay, so here is a geometric also. Okay, so yeah, you can use x like x geometry, so it's 0.66. Okay, so what is the probability for the first success occurs on the third trial? Then it will be probability for me to get my first success at the third trial. So x equals to 3. So it will be equals to, so meaning how many failure beforehand? 2 failure beforehand, and you have 1 success on your third time. So meaning your P, okay, then your Q will be 1 minus. Okay, then after that, what is your, how many failure you have? Yeah, 2 failure. Okay, so when you expand it, okay, when you use your calculator to find the answer, then you will be able to get 0.0763. Alright, okay, D. on or before the second trial. Okay, so if you try to write in a mathematical way, then how is that? Probability for you to get your first success on or before, so meaning smaller or equals to 2. So that's mean like first or second lah. Okay, so how can we do this? Yeah, so let's go to the normal way first. So when you want to find the first success happen on or before your second trial, is basically your first success happened at the first time and your first success happened at the second time. Okay, then you can 1, then meaning 0.66 lah. Okay, first time you get a success, so basically probability of P. Then after that you plus 1 time failure and 1 time success. Okay, then when you use your calculation, then you will be able to get 0.84. Okay, now I want to show you the other way. So it's the same thing. Now we try to think of this question in the other way now. Can we do this, use the other way? Yes. What is the probability for the first success occurs on or before second trial? Meaning, what is the condition that doesn't happen here? It's like after second trial, I didn't move. You get the idea? So meaning on or before second trial, meaning that the first success happened in the first time or the first success happened at the second time. So what doesn't happen is like 2 times I get failure. Because for me to get on or before, meaning first time I get a success or second time I get a success. So if I change this, then meaning what doesn't happen here is basically probability x greater than 2. Because my first success doesn't happen after second trial. So I use the complete probability minus the probability for me to get the first trial after, for me to get the first success after second trial. Then after that, what can I do? 1 minus, so you see, the probability for x greater than 2. What does that mean? That means, right, I didn't get a situation where 2 times I get failure. So that's why Q power 2. So 1 minus 0.34 power 2, then you will be able to get the exactly same answer like what you have got from here. Okay, so the idea of this is basically like finding it in a way that you have first success on the first time, second success on the second time. So for this one is what doesn't happen is like I get 2 time failure. Because if I get 2 time failure, meaning that the first success didn't occur on or before second trial. So that's why I use that to minus Q squared, then I'll get the answer. So from what you can see here, right, the first thing that you can find it out, I do not want you to go to this way. I want you to really understand why are you using this. But I'm writing here is just for you, for the case that for you, for those who doesn't catch it after this, then you can use this formula. From this question and this question, what do you realize? When you want to find the probability when x greater than, for example, here we use A. What happened? When you want to find probability when x greater than 6, then you use Q6. When I want to find probability when x greater than 2, then I use Q2. So meaning the first thing that I can have is this one is QA. Okay? So meaning that the probability for me to get a first success after A trial is basically meaning that I get all time, I mean I get, if A is 5, meaning I get 5 times failure. So that's why my first success happened after 5 times. Okay, you get it? So the probability for me to get a first success after A time of trial is basically equals to I get A time of failure. So this is what you can write it down so you can use it. So but you try to understand what is the idea behind that. Okay, C. What is the probability after the third trial? Okay, so what does that mean by after third trial? So meaning that probability for me to get a success after third trial. Yeah, so you can see this one is basically the same thing, repeat again. So the probability I get a success after third trial, meaning that for the first 3 times I always get a failure, so Q3. So it will be equals to 0.34 power 3, which is 0.0393. So this is the first way. So do you want to go for the second way? Yes, you can. Okay, so if you don't want to do that, then meaning that what you can try to do is equals to 1 minus. So you don't want x greater than 3. So meaning that, you want to find x greater than 3, meaning that you can minus off the one that x smaller or equal to 3. Okay, so you use 1 minus. So you want to find probability after third trial. So meaning that the case that you don't want is like first time you already get the success, second time you already get the success, and the third time you already get the success. Okay, then when you try to find it out, and you will be able to get the exactly same answer like this also. Okay, so it depends on you which way you want to go, but I will recommend you please get used yourself about the second method. So which is like to think of how many failure you have beforehand and so on. So that will ease your job a lot. And I think in terms of like solving question and so on, it will be very helpful for you also. Alright, okay, so let's move on for the next page. Okay, move on. Number 3. I toss a fair coin until I see the first head. What is the probability that I need for me to get a first head for exactly 3 toss? Okay, what does that mean? So you can see I toss the fair coin until I see the first head. So it's about the first success also. Okay, so exactly 3 tosses, then basically meaning that what is the probability for me to get my first success exactly on the third time. Okay, so exactly 3 tosses. Okay, so this will be equals to, then meaning you will have a success, then you will have a failure for 2 times. So this is why you get a first success on the third time. Okay, so you see, even though your P and Q is the same 1/2, but when you write it right, please do not straight away write 1/2 to the power of 3. I know that it means the same, but then you need to try to you need to try to write it in a way that you understand you are using your how many times of success times how many times of failure that you have. So please do not try to combine it together. Okay, so this is how you get 1/8, or if you want to do it in decimal, then it will be 0.125. Okay, so probability for at least 5 toes. So what does that mean? So meaning that your first success happen at the 5th toe or more than 5th toes. You get it? So at least 5 toes. So meaning that the first success happened at the 5th toes or more than that. Okay, so how do we find this? Yeah, so you can have 2 ways also. The first one is what you can try to do. Probability of x equals to, so you see what happened now is like you want x greater or equals to 5. If we want to change it in another way, right, meaning that it's more than how many times? It's not more than 5 times, right? More than or equals to 5 times is basically bigger than 4th time. Okay, so meaning like in another way, meaning like I need to do more than 4 tosses for me to get the first success. Then we will go back to the same thing that we have learned just now, something like this. Yeah, then what we can try to do, we use the failure and then power 4. So what does that mean by I need at least 5 tosses to get my first head? It's basically meaning that before that 4 times, every time I get a failure. So that's why I will need at least 5 tosses. Okay, so that's why failure for 4 times. Then this is how I get my answer, 1/16, then 0.0625. Okay, so meaning I have the other one here, which is if I have a probability for x greater or equals to a, what I will try to do is I will change it to more than, so I can understand what is that happen. So x greater or equals to a minus n. Oh, I'm sorry. Greater than a minus n. Okay, then after that, what I get? Same thing, I get QA. Okay, so probability for me to use at least a trial to get my first success is basically equals to the number of okay, I explain again. The probability for me to get at least a trial for me to get my first success is basically equals to probability the number of trials that I need is more than a minus 1, which is like greater or equals to 5, is basically greater than 4. Okay, then what do we do is like, it's basically meaning to failure then to the power of a minus 1. So it's like from this one you try to change it like the first one, then after that you use the formula. So but I say the same thing, please try to understand why are you doing this. So you need at least 5 doses, meaning that before that you get all the 4 time failure, then only you can do 5 doses, right? Yeah, only you can do 5 doses or more. So if you don't fail for 4 times, you cannot have at least 5 doses. So that's why the probability for you to get at least 5 doses is basically the probability for you to get 4 times failure. Okay? Alright, so now can I try to do this question in another way? Yes, you can. So if you don't want to do that, then the other way, the long one will be the probability x greater than 5 is equals to, so you don't want greater and equal to 5, then you use 1 minus x equals to 4, x equals to 3, x equals to 2, and then x equals to 1. Okay, so the smallest one is x equals to 1. If without trying, how do you get your success, right? Okay, then it will be equals to 1 minus, so the same thing, 1 success, then this one you have 3 failure, 1 success and you have 2 failure, and 1 success you have 1 failure, and then you minus 1 over 2 for the first time you get a success, then you will be able to get exactly same thing also. Alright, okay, so let's move on to number 4. In a particular country, 18% of the adults wear contact lenses. Adults are randomly selected and interviewed one at a time. Find the probability that the first adult who wears contact lens is one of the first 15 interviewed. Okay, you see, now they are not asking what is the probability of the first adult who wears contact lens is the 15 person that you interview. They ask like is one of the 15. So it can be the first one, it can be the second one, third one, fourth one, and so on. But it must be one of the first 15 that interview. So what does that mean? Meaning that you want to find the probability for your number of trial needed for you to get a first success is smaller than or equals to 15. So this is what does that mean by first 15. I can have like the first one I already got, second, third, fourth, and so on. So this is what does that mean by is one of the first 15 that interview. Okay, so how do we want to find the probability for our number of trial needed for the first success is smaller or equal to 15? Okay, so if you want to do this in a long way, then it will be x equals to 1, x equals to 2, 3, 4, 5, then you plus it up to 15. But you see the working will be very long. So what we can try to do, we use the same thing that we have already got just now. So the probability for you to get the number of trial for you to get a first success out of 15 or smaller, 15 or less trial, then it will be equals to 1 minus what doesn't happen. It's like your first success, you get it after 15. Okay, so the probability for you to get the first success in the first 15 interview is equals to what doesn't happen here. What doesn't happen here is basically equals to you didn't get the first one in the first 15, right? So meaning that what doesn't happen is that your first trial happened after the 15 person which got interviewed. So that's why 1 minus probability x greater than 15. Then you see you now having the same thing also. Then meaning what does that mean? So meaning that what doesn't happen is like you fail to get your first success within the first 15 person that you interview. So that's why Q 15. Okay, I repeat again. What happened here is basically meaning that the probability for you to get first 15 interview is basically equals to 1 minus if you got all failure for your 15 person that you interview at first. So this is what it doesn't happen, so that's why you got one of the first 15 interview. Okay, so equals to 1 minus 0. Sorry, I will write like this. So 1 minus your success is 0.18 and then to the power of 15. So 1 minus 0.050696 equals to 0.949. Okay, alright. So B, not one of the first 9 interview. Okay, so what does that mean? Not of the first 9. So 1 minus, okay, because not, so that's why we try to use minus, not of the first 9. So meaning what happened is not the first 9 that interview. Okay, so what does that mean by it's not of the first 9 that you interview? It's basically equals to you need people more than 9 people so that you only get 1 success. Okay, not one of the first 9 interview, in the other word, meaning that you need more than 9 people interview, then only you can get the first success, right? This is what does that mean by not one of the first 9. So that's why you see, meaning that I want to find the probability for x greater than 9. Then what is that? It will be equals to Q9. Not one of the first 9 meaning that I fail for 9 times. Easy, okay? So it will be equals to 1 minus 0.18 power 9. So I'll get an answer for 0.98 power 9, which gives me 0.168. Okay? Alright, so now by using this one, you see we can write another one again. Okay, so what is that? X smaller or equal to 9. So you see we have this also, so that's why we can try to write it. Okay, P X smaller than A. So if you want to find out the number of success that you needed is smaller than A, is basically equals to what doesn't happen is the probability for X to be greater than A. Okay? Alright? Yeah, from this one. I hope that you can understand, because I scared that like you find it like very difficult to understand when you want to think it in another way, because your formula only tell you that one. So I mean, of course you can use a very long method, but in cases like this, then it will be like very long and very tedious, and you have a higher risk to get it wrong. So that's why I want you to understand like there is another way to solve it, but you need to understand what you are doing. Okay? But I mean, if you want to memorize, then go ahead, but then I don't encourage you to do that lah. Okay, because it's basically something like common sense. You need to understand before you use it. Okay, so like what happened here is the first adult for the one of the first 15 is basically meaning what doesn't happen is for the 15th time you get all failure, so that's why you use 1 minus that one. Okay, so if I continue, then it will be, because it's the same thing, so I doesn't write it. Yeah, so it's basically like this. Okay, alright, so move on for number 5. A coin is biased such that the probability for obtaining heads for each toss is equals to 5 over 11. The coin is tossed until the first head is obtained. Find the probability that the coin is tossed at least 6 times. So yeah, you see question repeating. Okay, so at least 6 times, what does that mean? So meaning your first success actually occur on the 6th time or after 6 times. Okay, so if you have this, then what are you trying to do? So you need to change it to more than. More than or equal to 6 is basically equals to x more than 5. Okay, so you need at least 6 times is basically meaning that you fail for 5 times. Okay, So that's why 1 minus 5 over 11 power 5, then you will be able to get 0.0483. Okay, in another word, you need at least 6 times to get your first success, meaning that you fail for 5 times, then you only can have at least 6 times of those. Okay, so B, fewer than 8 times, so meaning Px smaller than 8. Okay, so same thing, if you want to do, then you can do 1, 2, 3, 4, 5, 6, 7, 8, but it will be very long. So we use another method to do that. So fewer than 8 times, so what is that mean that doesn't happen here? Okay, in another word, fewer than 8 times is basically equals to 1 minus what doesn't happen. So for 8 times, it's like 1, 2, 3, 4, 5, 6, 7 is the thing that you want to find. So the thing that you don't want is like above 8. So meaning like you get 8, 9, 10, 11. So that's why x greater than 7. You get the idea? Px smaller than 8, meaning 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7 is the thing that you want. So the thing that you don't want is 8, 9, 10, and so on. So that's why Px greater than 7 is the number of trials that you don't want. Then how do we continue? You see, we go back to this one already. So meaning what you don't want to happen is like you fail for 8 times. Sorry, you fail for 7 times. In another word, right, you get the probability for you to get the first success fewer than 8 times, meaning that what you don't want is you fail for 7 times. Because when you fail for 7 times, right, then you cannot get the number of trials that you needed for your first success is 8 already. Sorry, it's 7 already. So this is 8. So meaning that I want my number of trials needed for first success is smaller than 8. So that's why what cannot be accepted in this question is like I get 7 times of failure. Okay, so that's why 1 minus 5 over 11 power 7, it will be equals to 0.986. Okay, I really hope that you can understand. So please don't try to memorize, but I'm writing this like in case of like if you cannot really brain everything, right, then what you can try to do is you try to implement first, you try to apply first, then slowly you try to get it. Okay, so basically the probability for you to get the first success less than A times of trial is equals to 1 minus you get A time of failure. That is what you do not want. Okay? Alright, so, oops, sorry, this is A minus 1. Okay, so the probability for you to get x smaller than A is basically equals to 1 minus x greater than A minus 1. So like probability for you to get number of trials needed for the first success is 8. Then meaning that what doesn't happen is that you do not want your number of trials more than 7. Yeah, okay, then after that you do, meaning that you do not want you to fail 7 times lah. Okay, so 6. If x geometry distribution have a p of 0.4, find the probability x equals to 3. Okay, 6, 7, 8 is basically about non-application. It's like about notation. I would just want you to understand. So find the probability when x equals to 3. Okay, so basically it's the same thing. So meaning that you have 1 time of success and 2 time of failure. So that's why 0.4 and then 1 minus 0.4 power 2, then you'll be able to get your answer as 0.144. Okay, so 7. If x is a geometric distribution with p 0.8, then find probability for x smaller or equals to 5. Okay, so you can refer to this and change this. If you don't want, then try to think it. So meaning that what you want, the number of trial that you needed for the first success is smaller or equals to 5. So meaning what is that mean? Meaning that what you don't want is like you get 5 times of failure. So that's why you cannot have lesser or equal to 5 already. So that's why you don't want you to have more than 5 times of trial. So that's why 1 minus you fail for 5 times. Okay, so 1 minus 0, sorry, 0, yeah, 0.2 lah, sure away, okay, 0.8, so 1, okay, right, 1 minus 0.8, and then square, sorry, power 5, so 1 minus 0.2, power of 5, which will give you an answer of 0.9997. Okay? Can understand, right? Yeah, if you cannot understand, then you follow first. But if you can understand, please try to understand. Okay, so move on. Okay, last question. So the same thing, if x is a geometric distribution of p 0.4, then find out when probability x equals to 2. Okay, so we continue it. Okay, so probability x equals to 2. So first success on the second time meaning you get 1 time of success, 1 time of failure. So that's why 0.4 and then 1 minus 0.4, which is 0.4 times 0.6, which gives you 0.24. Okay, so probability for x greater than 4. So meaning that you need more than 4 times of trial for you to get the first success. So in an easier word, what does that mean? That means you fail for 4 times. Okay, so it will be equals to 1 minus 0.4 power 4, which is 0.6 power 4, then 0.1296. Alright, okay, C. So the same thing, I think this is the easy one. So number of trial that you need is 6 times. So meaning you have 1 time of success, you fail for 5 times. So 0.4, 1 minus 0.4 power 5. So which means 0.4, 0.6 power 5, and they will give you 0.031104. Okay, so move on for D. So this is like a conditional probability. Okay, I also want to use this chance to explain to you like the question of you like why you can multiply sometime, why you cannot multiply sometime. So probability for x equals to 6 given that x greater than 4. So when you reuse the formula, then it will be probability x equals to 6 intersect x greater than 4, then divide by the probability x greater than 4. Okay, so you see, my question is, x equals to 6 is event A, x greater than 4 is event B. Are they independent? No, because why? How you can check? If they have intersection, right, meaning they are not independent already. Okay, so you see, x equals to 6, what does that mean? Meaning that you can accept x equals to 6. X greater than 4, meaning that you accept 4, 5, 6, 7, 8, 9, 10. Then what you realize, you have a 6 in common. So that's why this is not independent. Okay, so meaning that when you want to find this question, then what do you need to do? Meaning that you need to find out what is the intersection point, then find out the probability. So x equals to 6, x greater than 4. Where is the intersection point? It's at 6. Meaning you see the first event I have 6, second event I have 4, 5, 6, 7, 8. So you see what's the common thing? 6. So that's why probability for x equals to 6 intersect x greater than 4 is basically equals to probability x equals to 6. Okay, and then divide by probability x greater than 4. So probability x equals to 6 is 0.031104 divide by the same answer that we got here. Then after we put it together, then you get 0.24. Okay, I really hope that you can understand the whole thing. So if you cannot, then when you first try, you can try to write this out first. So as you apply, then you try to understand what is that mean. Okay, so alright, Have a good weekend and try to do your exercise. Thank you.